Hi all, it's Shiva, Director Strategy of Chaos Renewables. This is the last session of our webinar series on risk and benefits of solar power plant. In this session, we will cover how you can choose a grid-tied solar power plant based on the key performance indicators of the inverter as well as solar panel. Now, if you consider a grid-tied inverter, the basic thing I spoke about was in my earlier sessions. The fundamental thing is that an inverter works after synchronizing with the grid power from the utility. So the grid power essentially complements the inverter solar power. And when you consider that inverter, a solar inverter, it has two key components. One is the MPPT, or a maximum power point tracker, and second is an inversion unit. The function of the maximum power point tracking circuit is to extract maximum DC power from the solar modules. We're not going to get into the technicalities of how it functions, but for all practical purposes, what it does is even if there is a cloud cover, even the temperature varies or whatever externalities, it kind of ensures that the power extracted from the DC modules is the DC solar modules is maximum. And the function of the inversion unit is to take this DC power, convert it into AC, and synchronize with the grid. This is the key function. Now, as I spoke earlier, the inverter, a grid-tied inverter, functions only if the grid power is available. So if there is a power shutdown, the inverter stops. So the synchronizing with the grid, matching the frequency, the voltage parameters, all that is also a function of the inversion unit. Now, before we get into the KPIs, let's understand the three basic solar inverter architectures when it comes to rooftop solar plants. So there is the traditional string inverters. So the string inverters typically have DC cables connecting the solar modules, and they might have multiple solar modules connected in series. And when you connect multiple solar modules in series, it's typically called a string. And we might have multiple such strings connected in parallel to different MPPTs. And in such inverters, typically the MPPT and the inversion units comes in a single box. And the solar panels are connected in series, so there is a high voltage DC present. Each module typically has a VOC around 48 volt. Let's assume it's 50, so if there are 10 panels, it's 500. If it's 20, it's around 1000. And if you have multiple strings, typically the systems which we have in rooftop are all 1000 volt DC systems and never exceeds 1000. So you might have multiple such strings connected in parallel to a single MPPT or multiple MPPT. In such systems, one MPPT or DC power extractor typically manages somewhere between 15 to 20 modules. That's the standard range. It might be lower if the system size is smaller. And such systems typically give a warranty of 5 to 7 years, such inverters. And now we have another kind of topology which we call as the micro inverters. So as the name suggests, in such case you will have multiple inverters under the solar module. So each module will have its own micro inverter, and all these inverters will be wired in parallel, and it will be connected to your meter directly. So there is no DC wiring here, and there is no high voltage DC, only that 48 volt DC which is coming from the inverter, from the panel, which is converted directly by the inverter to 240 volt DC. So that's how the system works. It's a completely parallel modular system. and on and then the third architecture is kind of a hybrid. So what it does is it splits the functionality. So they take the MPPT and keep it at a module level, and this unit is called an optimizer, and these optimizers are connected to solar modules, and then these optimizers are actually wired in as a DC circuit. So in this system, the DC power extraction unit is separated and is kept on the roof. So you have a unit for DC power extraction and you have another unit for inversion of power. Typically, this particular DC power extraction unit has a warranty of 25 years, and this particular inversion unit has a warranty of 12 years, which may be extended to 20. In case of microinverters, the warranty is 10 to 25 years. Standard is 10, you can extend it to 25 years after paying an incremental amount. So these are the different inverter architectures. Now we will talk a bit more on the advantages of these architectures in the later slide. So this is the basic architecture, traditional one. Both of these together are called module level power electronics. So this is a bit more advanced and a bit more expensive architecture. Now when we come to key performance indicators or KPIs for choosing a solar power plant, the first one typically which comes to everyone's mind is what you call as an efficiency. And if you look at the data sheet of any module, you will see two efficiency, which is peak efficiency and then something known as a European or California weighted efficiency. So the peak efficiency could be somewhere around 99% and the weighted efficiency will be somewhere 97% plus, typically for a good inverter. And if you look at what is this weighted efficiency, I would recommend googling a bit on European and California weighted efficiency to understand it a bit more. Under Indian condition, California weighted efficiency is a bit similar to the efficiency of the inverter in Indian conditions. So I would recommend looking at this as a metric rather than the European weighted efficiency. So just to give you a quick view, the inverters typically operate at different loads during the daytime. So during the morning it might operate at 10% load, that is when the solar production will be low. Then it might reach somewhere around 60-70% during noon. Again in the afternoon, during the evenings it will come down. So it will operate at different points in this efficiency curve throughout the day, and the weighted efficiency kind of gives us an indication of what is the actual efficiency which you get out of the inverter, considering its operation at different points in this efficiency curve. Now when we look at KPIs, one of the most important metrics is number of solar modules for each MPPT. So it ranges very broadly from inverter to inverter. Even in string inverters, you have systems where you have a single MPPT managing 200 modules. So this sometimes can be very tricky because the DC power extraction unit, when we connect all the modules in series, find it difficult typically to manage all the modules performance together. This is because in a series circuit the current is constant. So if anything happens to one of the modules, either it might be a shading issue, dust accumulation. We spoke of mismatch earlier, right? The string inverter might struggle to manage that mismatch, and that might lead to a lower production. So I will cover this in a bit more details why this ratio of number of solar modules for each MPPT is very important. I will cover that a bit more in detail. Now the MPPT start voltage is also another important parameter. So this kind of decides at what point you start getting the production. So if you have a module in the mornings, it will start power production. So to start the power production, the inverter requires a minimum voltage from the module. So that is what the MPPT start voltage is, and the operating range is also important. Once it gets into that voltage, at what range it can operate. The level of monitoring is also very important. So if you want to debug an issue in the system, whether you are getting the data at a solar module level, whether you are getting at a group of 20 modules, group of 200 modules, that is very important. So many string inverters have string or inverter level monitoring, and some inverters have no monitoring. So you need to be careful about what level of monitoring you have in the system. Quality of power is also important. So there are certain guidelines by all utilities in terms of the allowed harmonics and the frequency range, the voltage range the inverter can operate. So these parameters are also required. An important parameter, and how you can adjust it remotely also becomes important if you are in a remote area where the voltage might fluctuate beyond the standard range provided by certain manufacturers. Now, the safety of the system is of paramount importance. So, like I said, the microinverters have an inbuilt, by design itself, they are very safe. But if you take string or optimizer design, you can have some mechanisms to ensure safety, like arc detection, or safe DC, which is a feature in optimizer. You can google that to understand a bit more on it. But you also should look at safety as a feature in an inverter. How it ensures that it can detect a DC arc and warn you is an important element, and how it can ensure that you have a safe roof when you are cleaning the solar panels. So all these are important. Now, if you look at architecture, one inverter architecture which I didn't spoke of was central inverter. So central inverters are typically very big in size, and it's not that much used in plants below 100 kilowatt. So one inverter will be 100 or 500 kilowatt or a megawatt or 2 megawatt, and these inverters are similar to string in the design, but you will have a large number of strings which form what you call as an array. When you have a large number of strings connected in parallel, it's called an array. I explained strings as a number of modules connected in series using a DC wire earlier. So that's the difference between a central and string. The key difference is the size of the system and the number of MPPTs which you have in the system to manage a certain number of modules. The last architecture, broadly it's called module level power electronics, where we have optimizer and microinverters. So if you look at cost, central inverter string will be always cost effective, but if you look at other parameters like efficiency, effectiveness, granularity of monitoring, or product warranty, the module level power electronics will any day beat the central inverters and string inverters. Now, I want to cover a bit more on what is mismatch losses here. So, let's say you have a inverter where all modules are connected in string. So, then what happens is, let's say all these modules have some issue in typical string. This may not be the scenario, but let's assume that this is the scenario. Then the least performing module will actually decide the performance in case of a string inverter, because all these modules are connected in series, and series connection means current is constant. So even though some modules are performing at 100%, 90%, 75%, you still get the least performing modules output in a string inverter. This is very important, because when you look at long-term performance of the system, the mismatch losses typically increases over a period of time. It might be due to new shading, new obstructions coming around the building where we have put the plant. It might be due to poor quantum, or inability to clean the modules that frequently. It might be due to non-linear degradation. So all the solar modules need not degrade at the same rate. So after 10 years, typically what we have seen in certain studies is the mismatch due to degradation is around 7%. So what that means is, inherently some modules might be at 300 watt after 10 years, while some others will be at 293 watt. And in a string inverter, you will get only 293 watt output. But when you have module level power electronics, that is systems with optimizer or microinverter, they have the ability to extract maximum power from a module level. Because in optimizers you have the MPPT at a module level, and in a microinverters you have the microinverter at a module level, which will extract maximum power, leading to maximum power extraction from each module. And optimizers have certain limitations if the number of modules in a particular optimized search string is more than if let's say 50% of the modules in an optimized search string has a defect, it might limit the optimizer's performance to some extent, but still it is far better than having a string inverter. Now, as you can see, this is a module level monitoring system. So here you can see each module's production at any point of time, compared to a string level system where you can see strings data at any point of time. Here you can see each module's data. So you can see that certain modules have relatively low performance compared to this. So this might be because of a change in orientation. So this might be south facing and this might be east facing. So in a typical system, if you wire it as a string, then you get possibly only the 16.9 kilowatt or 16.6, actually 16.4 in all the panels. So this kind of shows you the power of module level power electronics. And you can also see some advanced parameters like DC voltage, AC voltage, DC current, based on the kind of inverter which you are using. So to what extent you have data, it helps you in debugging the faults which you have or which you might have in the system. And all this, if you can do remotely, you as an installer can save a lot of time in service visits, and you as an end customer can raise a ticket and sit back at home and get an inverter replacement. So the power of monitoring is very important when you look at the long-term performance of a system. You can detect module defects, you can figure out any issues with the system very easily when you have this level of visibility. Now we are done with the inverter piece. So I spoke of how we can go about choosing an inverter. Now let's try and understand solar modules a bit. So typically what we see in the market today, the module ratings for a 72 cell module of size 2 meter by 1 meter, the watt peak rating typically range from 315 to 415. And I'm not sure whether you recall me speaking about solar not being a constant source. So what it's called watt peak because of the same reason, because it's the peak power which the inverter which the panel can deliver. So it's not like a generator where you put 100 watt generator and you get 100 watt. So that's why whenever we talk of module rating, we talk in terms of watt peak, not in terms of wattage. Now, and all module specification is typically done at standard test conditions. So it's at a radiance of 1000 watt per meter square, cell temperature of 25 degrees Celsius, and at an air mass of 1.5. So this is the STC condition. And the efficiency for a module typically it's kind of decides the size of the module, because for a solar module the input power is decided by its size. For example, 200 watt peak module, if it's 2 meter by 1 meter, will have an efficiency of approximately 10%. And if the same 2 meter by 1 meter module can deliver 400 watt peak output, it will have an efficiency of 20%. So efficiency kind of decides the size or the space efficiency of the system. One important advantage which we have when we have higher efficiency other than the space effectiveness is these modules can produce power under low light conditions. So with higher efficiency modules, you tend to gain some more power production during early mornings, late evenings, as well as during rainy conditions or cloudy conditions. Now, when you look at another important factor which we always look at is the product warranty of the system. So what is the product warranty for a solar module? It typically varies from 10 to 25 years if you're looking for a standard system. And the performance warranty typically varies from 25 to 30 years. And performance warranty, all manufacturers gives at a degradation rate. And that degradation rate ranges from 0.35% to 0.7%. Now, product warranty covers product defects. So this is kind of the real warranty which you get. So any module which has a product warranty of 10 years and let's say a performance warranty of 25 years, and let's say in the 11th year that module has a discoloration or breakage, and because of it its performance went down, you can't actually claim it under performance warranty because it's a product defect which happened after 10 years. If the module is intact and there is a performance defect, that's where you can claim performance warranty. So product warranty is always better than performance warranty. And this degradation rate, so I will give you, I mean every module it degrades in performance over a period of time. So typically the standard degradation rate is somewhere around 0.5%, but the warranty which the manufacturers give varies from 0.35 to 0.7%. So in the first year it will be slightly more, it will be around 1.5 to 2.5%, but afterwards it comes down to 0.35 to 0.7%. And another important factor which we need to consider is the temperature impact. So as the temperature goes up, the module efficiency actually comes down. So like I spoke in the beginning, the solar PV panels work on light, not on the temperature. So if you look at the the factor which decides how much the temperature has an impact on the solar module's production, it's called temperature coefficient. So the temperature coefficient typically has a range from 0.29 to 0.44%. It's a negative value. It's negative 0.29 to negative 0.44%. So for a good system typically have less than 0.4% degradation. Minus 0.4%, lower than minus 0.4% is always preferred compared to so basically 0.44 is bad, minus 0.4 or minus 0.29 is good. So what it means is for every degree rise in temperature above 25 degrees of the panel surface temperature, how much does the module's efficiency or performance comes down is what it means. So at 26 degrees for this particular panel, the efficiency will come down by 0.36% or output will come down by 0.36% compared to the 25 degree value. So that's what the temperature coefficient means. And it's very important because during daytime, if you take the Indian climatic conditions, the module surface temperature will be somewhere around 50-60 degrees in most of the places. So this has a huge impact on the actual output which you get from the solar module. And another related parameter is what you call as NOCT or NMOT, normal module operating temperature or normal operating temperature. So normal operating cell temperature. So this kind of gives you an indication of the heat sink which is present in the module. So the lower the better. Typically you see values starting from 44, 45. Plus or minus 2 is the typical value which you find for this, but certain manufacturers have tried to bring it down a bit further. I mean, beyond this, you should also look at the product certifications for compliance, quality checks, manufacturing process, credit rating, what is the module design, etc., etc., to get an understanding of the reliability of the module. You might have a good data sheet, but it always need not reflect a good quality product. So it's always better to go with a reliable brand who does good quality checks and who has a good credit rating, so that we are sure that the module doesn't go bankrupt over a period of time. Now, if you take module technologies, we have monocrystalline, polycrystalline, thin film, polyperk, monoperk, heterojunction. You have so many technologies, so you can Google all this and understand a bit more on that. So we started with poly, thin film, and mono, and now what is more popular is polyperk and monoperk, and half cut poly and half cut mono. So now these technologies, the perk technologies and the half cut partners, are more popular in the market compared to other technologies which you see here. But poly is still very popular because of its low cost. But I mean, the other parameters, the perk technologies beat it. So I think we are moving towards an era of perk, at least in the coming years. You can Google these technologies a bit more to get a better understanding on them. Now, with this, we have covered the key performance indicators of both solar modules and inverters. So keep this in mind while you are trying to choose a solar module. And with this, we are also coming to the end of this webinar series on key benefits and risks of solar power plant and how you should go about choosing a solar power plant. And again, it's not a comprehensive guide, but these are the basic things which you should look at while choosing a solar power plant. I hope everybody understood the sessions. If you have any questions, or please leave a comment. If you have any inquiries on solar power plant, please feel free to visit our website and leave an inquiry, or feel free to reach out to us at info@chaosrenewables.com. Thank you for your time.